All right, so we're going to start with example 3. We are going to look at a confidence interval comparing two different population proportions. So in 2013, 2,000 men and 2,000 women were randomly selected for a Pew survey. Interviewers reported that the proportion of men who felt that embryonic stem cell research was morally wrong was 23%, 0.23, and the proportion of women who felt it was morally wrong was 21%, 0.21. Right, we wish to find a 95% confidence interval for the difference of proportions between men and women who feel this way in the population. And then based on what we get from our confidence interval, then we're going to go from there. So there's a little note here underneath what we want to know. It does not matter what we choose as population 1 or 2, as long as we stay consistent with this choice throughout the process. So we will start with N1. Our first population is all American women. Okay. All right, and then N2 is going to be the population of all American men. Again, it makes no difference which one you choose. If you're told to specifically choose one as population 1 or population 2 in the homework, pay attention to that. But if you're otherwise just working through it, it doesn't matter which one you choose as long as you stay consistent as we go through the problem. So focusing on our first population, the American women, there were 2,000 women sampled. And P1 hat then that we're given is the 21%, the 0.21. We are also told that there were 2,000 men sampled. And P2 hat is going to be 0.23. We are told to use a confidence level of 95% in this problem. And what we want to know, the confidence interval, which again is always set up with P1 first. So P1 hat minus P2 hat plus or minus M. And what we're really looking for, right, is 0 included? If 0 is not included, right, are both values positive, making P1 the larger proportion? Or are both values negative, meaning P1 is the smaller population? So again, as we're going through and we're thinking about interpretation, there's kind of a couple of different levels to what we're going to have here. All right. Now, I am including conditions for these two, partially because this is going to be the information that we're going to plug into StatCrunch. And just to kind of also point out the fact that we have two populations that we're working with, so we need to check our conditions of our central limit theorem for both of our populations. So when we start and we look at this, notice that we have for population 1 and for population 2. For population 1, remember up at the top, we stated that that was women. And then for population 2, we stated that that was for men. So we're going to go through and check our conditions for both of our populations. Sample is random and independent. Yes, we're always going to assume that's true unless we're told otherwise. That there are 10 successes and 10 failures. Right? So 10 successes is going to be N1 P1 hat. Right? And we're going to multiply that. So N1 is 2,000 because we have a sample size of 2,000 women. P1 hat is 0.21. This gives us 420, which is greater than or equal to 10. And then we're going to take 2,000 times 1 minus 0.21. That gives us 1,580, which is also greater than or equal to 10. Now, again, as I kind of did before, when we pause here for just a second, remember that when we're plugging things into StatCrunch, our sample size and our X are the values that we need. So our N1, right, is going to be this 2,000, right, and our X1, right, that we're going to enter into StatCrunch is going to be this value right here. So we have N1 and X, that should be a subscript, X sub 1. Right. Our large population, all women greater than or equal to 10 times 2,000. Well, 10 times 2,000 is simply 20,000, and there are definitely more than 20,000 women in the United States. Right, now we're going to go through and we're going to check our conditions for our other population for men. Sample is random and independent. Yes, we're going to say that's true unless we're told otherwise. N2 times P2 hat. Our sample size for the men was also 2,000. P2 0.23. Right, we multiply these together. That gives us 460. Right, 10 failures, 2,000, which is greater than or equal to 10. 2,000 times 1 minus 0.23 equals 1,540, which is also greater than or equal to 10. Again, the number that we have here, this 460, is our other x value. So that's our x2, right? And then our n2 that we're going to use for StatCrunch was this other 2,000. Right? So as we're going through and we're checking our conditions, remember our number of successes are numbers that we're going to use for StatCrunch. All men greater than or equal to 10 times 2,000, which is 20,000. Right. We're going to assume that that is also true. All right, so then we're going to plug this into StatCrunch and we are going to find our interval. Right, so we plug this into StatCrunch and find our interval, and what we end up getting back is our interval is negative 0.045 to 0.005. Okay, so there is our interval. All right, so now we need to look at this interval and ask ourselves, does it include 0, are both positive, or both negative? Well, anytime we have one negative and one positive, that means that our interval contains 0, right? Because in order to go from negative to positive, you have to pass through 0. So for our interpretation, I'm going to try to squeeze it down here tiny in the bottom. The confidence interval, we'll just use CI as in just kind of a short notation, includes 0. So we cannot rule out the possibility that the same percentage of men and women feel that stem cell research is morally wrong. Right. So since these two possibilities, we plug all the information into StatCrunch, we end up with a confidence interval that includes 0. We cannot rule out the possibility that the same percentage of men and women feel that stem cell research is morally wrong. So again, we didn't need to go into whether or not they were both positive or negative because that wasn't the case. It included the 0, so we said we couldn't rule out the fact that they could be the same.